Raise your hands if you've heard of this thing called direct variation. Let the record show only 3 or 4 hands go up. Okay, this is a little bit different. The funny thing is that the roof problem, the one that you just did, is an example of direct variation. Okay? But you just don't know it yet, so I'm going to point that out to you. Okay, the idea behind direct variation, or when we say something to the effect of, who's heard this statement before? Y varies directly with X. Has anybody ever heard this statement before? Juliana has, yeah? Brian has. What does that mean? Y varies directly with X. Yes, exactly. That's what it is. Here's what this means. This means that Y is equal to some constant times X. So the number out in front of your X in terms of structure of mathematics, this is your constant. Your constant of variation. Okay? So if y varies directly with x, that means we can set up the equation y equals kx, where k represents our constant of variation. You should also be making the connection right now that k is the exact same thing as that word that starts with an s. Slope. Yes, it is. Okay. So if it's true that y is equal to kx, then we could say that k would be equal to what, you guys? It is the slope, but in terms of y and x, what would it be? It'd be y over x, okay? Absolutely, k would be y over x. So this is what we mean by we're talking about direct variation. There's everything you'd possibly want to know about direct variation. Okay, so we're trying to determine whether or not the table of information given to us represents direct variation. dv is our direct variation. Nick, what do you think, my man? Very good. Yeah, he's absolutely right. Okay, so here's what we're going to do. We're going to check the value of k, which remember is just y divided by x, because that's what it says right up here, right? K is nothing more than y divided by x. So if we check the value of k, let's take each y value, that'd be 2, and divide it by the x value, which is 1. Is that the same thing as 6 over 3? Is that the same thing as 8 over 4? Well, let's see here. 2, 2, 2, So yes, this represents direct variation. Straightforward, right? Flows like falling asleep back over there, okay? Why is this one not direct variation? Because k would equal 4 over 1, which must equal 8 over 2, which should equal 11 over 3. Well, that's a 4. That's also a 4. That is not 4. Therefore, this one is a no, right? All right, now I have two equations here. I have a and b, 3y equals 7x, and I have a 7y plus 14x plus 7. There's an equal sign there. All right, which one of these is direct variation? Which one isn't? Why or not? Juliana, what do you think? Yep, so if we divide by 3 on both sides, we would see y is 7/3 x. Sorry, that should be an x, by the way. Okay, so that means that the constant of variation in this case is 7/3. So it has the proper form, it has the proper structure of direct variation. Is that what I'm hearing? Okay, how is that different than B? Juliana, again, if you want to take it. Yeah, we would get 14 over 7x and then plus 7 over 7. So if we just simplify a little bit, we would see that we'd have a 2x and then plus 1. So how are these different? Yeah.
Well, that one is in the form k equals, that one's just in the wrong form.
Yeah, it has the wrong form, right? This is in the form of y equals mx plus b, right? So you should realize that, yes, the constant of variation and the slope are in the same spots, but what's different about this one? It has an extra b to it, right? So yeah, the second one, part B, would be no, that's not direct variation. Y does not vary directly with the x. Okay, so here's the setup for you try. You know that y varies directly with x. I'm going to tell you that y is a value of 9 when x is a value of negative 15. I'm asking then, what is the value of y when x is 21? And there's a couple different ways you can set this up. Please set your work up and share it with your neighbor, and then we'll talk about it as a class. 21x over y, is that what you did? 21. Okay, so how did you come up with this? What is this, a ratio or a proportion? What is this, you guys? Yeah. Does anyone else have this? Okay, okay. It doesn't matter in terms of the procedure, right? But in terms of if we start with y equals kx, then we know that k is equal to y divided by x. Is that true? And we know that the first one, 9 over the x was negative 15. Is that true? So we had that one, right? Okay, so then that must equal the other k, which would be y over x. We don't know what the y is, but we do know the x is 21. Is that roughly the same idea? Okay, good. From here, Rachel, what'd you do? There you go. 9 times 21, so you end up with y being negative 12.6 when you do this, right? You guys got? Anybody set it up differently? Nick, what'd you do, my man?
I first multiplied y by 7 and then divided it by 5.
Why did you multiply y by 7 and then divide by 5?
Because, well, I just basically did it backwards. Or I'll just explain dividing it by 5 first and then multiplying it by 7.
Okay.
So x divided by negative 5 is 3.
X divided by negative 5. Wait, what'd you say?
X divided by negative 5
Mm-hmm.
is 3.
Oh, okay. Yeah, I'm with you.
9 divided by negative 5 is 9 over negative 5.
9 divided by negative 5.
This one. And then,
Nope.
since 3
Mhm.
times blank equals 21,
Mhm.
the blank is 7. And then you multiply 9 over negative 5 by 7, which is
So gnarly, dude.
and it's the same.
I love it. He's just so around the clock. I love it. That's awesome. Okay, I can always count you for the alternate solution. I'm great. You're my guy. All right, so I'm going to give you an equation. I'm going to say y is equal to 3.7x. Would you guys agree or disagree that that equation is a direct variation equation? Agree or disagree? Agreed. Okay, I want somebody else shout out a different one. Give me anyone you want to make up. Y equals, I heard 2x in there. Give me another one. Y equals 4x. Good. You guys are easy. Give me something hard. Hold on a second. Y equals 1x. Okay, give me something like funky. Ooh, y equals 1,000 over 923x. Ooh, I like that one. Y equals root 2x. Okay. Oh, that's kind of funky, right? So square root of 2x, and then how about that? Do we get that? Good. Okay, so I'm going to put these on a graph. I'm going to put these on a graph. Do you guys notice anything? I don't know. Do you guys see anything that's kind of interesting about those graphs aren't there? What do you see, Brian? What do you see, my man? They all cross the origin. Nick, what were you going to say? X equals 0. Yeah, and all of that, yes. And y equals 0. Yes, Mia. Fun. Okay, all right. Graphs of explorer. Here, I'll show you. Okay, so we're going to take this information, you guys. We're going to put it into our notes, and it's called this. So here's what I did for you. I wish you guys do the same thing. But what can we conclude from this information here, ladies and gentlemen? Yes, that all graphs of direct variation, and then fill in the blank for me. All graphs of direct variation do what? Pass through the origin. Nice job, Jake. Pass.
They're slope intercept, but since the origin's always 0.
There you go, my man. All graphs of direct variation pass through the origin. That is box number 4. And tell me everything you know about slope right now. Shout it out. What do you have? Yeah. Okay, slope is the variable m. What else do you know? It is the rise over the run. I like that. What else? y2 minus y1 over x2 minus x1. Good. That's the slope formula. Good. What else do you know? Delta y. I like that. Delta y over delta x. What do the delta means? Deltas mean change in, right? Change in y over change in x. Good. Yeah, Nick, what else?
0 slope equals a vertical line. No, horizontal line.
Okay, so there is something called zero slope. Okay, is there such thing as called positive slope? Yeah, there's something called positive slope. Is there something called negative slope? Yeah.
Positive slope faces the right side, negative slope faces the left.
Yeah, and is there such thing as an undefined slope? So we have all these things. We are brain dumping right now. Everything we know about slope. You guys are all right. Is there a certain type of linear function that I wrote down earlier in the lesson that has something to do? Yeah, and then this all ties together of y equals mx plus b. What's the m represent? And what's the b represent? Okay, so this is kind of the culmination of all these things sort of put together here. This is nothing new for you in this class. I'm just making sure that we're having the conversation about it, okay? Here's what you do now. For a 0, a positive, for each one of these situations, can you give me a quick sketch of what this would look like to the right? Okay. So we have 0 slope is a horizontal line. A positive slope goes up from left to right. What about a negative slope? Goes down from left to right. I agree with that. And what about an undefined slope? That is a vertical line because there is no change in the x for an undefined slope, right? Very, very good. Okay, nasty. Okay, we're going to graph this together. 2/3 x plus 1/3 y equals negative 1/3. Do you guys want to leave it like that? What do you want to do? No? Okay, yeah, what's your suggestion there? Multiply the entire thing by 3. Why? Yes, let's multiply both sides by 3. So that would give me what? 2x plus y equals negative 1. Good. Then what would we do? There you go. Y equals negative 2x plus 1. How do you graph this line, everybody? Yep. So here you go. So give yourself a coordinate plane. Looks like this. So we'll bring this over for you. Boom. Coordinate plane. Okay, negative 2x plus 1. What should I do first? Go down 1. Very good. That's my intercept. Then what? Then what do? Down 2 from there and go over to the right 1. So notice that I have a negative slope of negative 2 right there. And the intercept is 1. Okay, ladies and gentlemen, here you go. This is box number 8. Check it out. I have given you this beautiful line up on the screen. I would like you to determine the equation of this line, and then we'll call it a day. Okay, who agrees with Becca at negative 2 or 5x plus 4? What's the slope of this line? Negative 2 or 5. Now, how did you get the slope? What did you do?
I saw the 4.
Yep.
And then I tried to find the next one that passes through a point.
That one? So the change in y would be down 2, and the change in x would be over 5, and that's where the slope comes from. It's the ratio of change in y over change in x. It's negative because the line goes down from left to right, and then what's the plus 4 indicate? That's where we start. Absolutely.